personal. Good morning again, because I started the recording. And good night, Kojak, but don't fall asleep yet. Not just yet.
Yeah.
Okay, so I was lazy because I had a major launch this week, collaboration announcement as a digital creator, which has obviously nothing to do with token engineering. So I'm sorry, guys. I will just leave it all to Roro.
Oh no!
I was thinking
5 minutes ago, I said more or less the exact same thing to Ruan.
I know.
Oh no. Okay.
Also, by the way,
Because I had exams this week and just too much on my plate.
right.
Lutra, for some reason, your voice is very garbled for me. Only yours.
Yeah, it's a little bit, but it's fine for me. But y'all missed Lutra wearing a proper suit and tie, and it looked really cool.
Wait, what? Where?
Yeah,
Yes.
Pictures.
right before
Proof.
you joined.
Oh,
I was
no.
telling him not to change. I was like, you look great. Why are you changing? But he needed to change for some reason.
I wanted to be more comfy, I would assume.
Yes, exactly.
I
But
understand.
if you like, I will present myself in a suit with tie and so the next time.
All right. Okay, so I was thinking we could try to convert the math to code, like one by one, because that was something Kojak wanted to do, right?
Yeah.
Right. So
Yeah, fine. One sec.
Kojak, what's on your mind?
yeah.
Speak.
Yeah, one sec. What's on my mind is trying to blow up, get into streaming so that I can see this Roro's screen better. 1 minute, what do I do?
Should I zoom in?
If you can.
This is the max we can do.
That's very good. That's okay. But I'm trying to, I can blow up my screen, sir.
Or you can click on my thing, right? I think it'll, if you click on my,
I clicked on yours, but then it's okay now. Now it's your code is highly readable now.
okay, great.
No, the thing is that what I really wanted to this thing was to connect up with you to actually straighten out be able to run the code on Collab, the thing.
Yeah.
When are you free? When can you spend maybe an hour?
Anytime after. I mean, we can do this after the call too. I have 10-15 minutes after the call. But
will that be sufficient?
Yeah, if you can share your screen, we should be able to figure. Otherwise, tomorrow, I don't mind. I'm more than happy to help.
Tomorrow, Saturday, can you slot some time?
Yeah, surely. We'll book it on my calendar.
No, the thing is like this, because I want to get back into this and CAD and machination, all that stuff, because,
Sorry.
Wait.
Okay, so what we can do now, I was thinking, was first take the screenshot. So wait, let me add a text and put an image. I don't know if that, no, not that. Okay, kind of. That did work actually. Yeah. So this is the image that we're trying to convert, like this equation. Okay.
Yeah.
Right. So this is the equation for so in order to figure out what.
Let me just ask. I kind of figured it out for this thing. So Stella, Stella Luthra? Have you also figured it out how this translates into code?
No, I haven't worked on it, like I said. So feel free to do it if you think you have.
No, I'm thinking also it's worthwhile going through this because you guys have been in this situation quite often where you will see an equation that someone's written on math and you want to maybe convert it to Python.
Fine. Go ahead.
Yeah.
Fine. If Luthra and Stella want it, fine. Perfect.
Yeah. Okay. So the way usually I would do it is first I'll try to But, let's say we know what x is, okay? So we'll first assume that we know certain things. Let's say x is 100. Let's say y is 20. Just to give some numbers to the what we're doing.
Sorry.
Let's say
Matthew.
delta. Yeah. Delta x is, let's say, 10, maybe. And so I'm trying to name variables a little more in the style of the way it's done in the code, in the math section itself. So we'll call, we need x, we need delta x, we need y, and delta x we already have. So if we actually just give them certain like random numbers, we can actually figure out what delta y should be for these variables, right? And do we remember what these are, by the way? Like, Stella, x is the
Yeah.
number of tokens in the
Yeah.
pool currently, right?
Yeah, of token X. Yeah.
Yeah.
Y
What is
of
y?
token Y, right, in the pool,
Yeah.
and delta X is the amount being taken out
Yeah,
of the
exactly.
pool of token X, obviously. So
Yeah.
Y is the amount, delta Y is the amount of at the same time of token Y that are getting taken out of the pool.
Correct. Yeah. Yeah. In this case, if you see the way delta y was defined, it was x plus delta x and y plus delta y.
Yeah.
So what delta y represents is how much tokens we are adding to the system. This answer will turn out to be negative simply because delta y like is coming out of the system, not going in. So the negative sign represents what's coming out. But either way, it's there in the, for us, all that matters is it's there in the equation itself.
But it's good, so we
And
know that not X is being taken out, but instead Y is taken out, right? So that's
yeah,
good for us. So
yeah,
we know.
yeah.
Okay.
And the way I would go about this is that I would usually put a variable called numerator, let's say, and try to write what's there on top, which is this, right? So I will do negative y times delta x. Also stop me if you all are confused at any stage. And we'll represent the denominator separately. NATO, I don't know how to spell that. Yeah, that's right. Which will be x plus delta x. So it's much easier if we keep the variables the same. Sometimes in your code you will not be able to, but because x and y are again very common things, and that's what I think Stella was pointing out that Andrew was telling us, right? Like that.
Yeah.
X and y are very common variables. Ideally, you shouldn't use them all over the place. But again, for us, it's not like we're writing extensive code. If you're only writing parts of a system, fine, whatever, right? As long as
I
yeah.
actually really like how, I mean, you met Mark, right? Mark does it by saying TKNX, TKNY. I think this is a good placeholder.
Token X, token Y. Okay, right, yeah.
Exactly. I think it's a
And
great
in this case, let's just
placeholder.
stick to this. We'll change it later.
Yeah, sure.
Yep.
I'm just saying this is like from coding perspective so far, the variables where I was like, oh, that makes a lot of sense. Like everyone can read the script, you know?
Yeah. Yeah, makes sense. I mean, the more descriptive you are in general, it helps. But yeah, this is basically what I've done. I separated the numerator, denominator, and I divided them to get delta y. Does that make sense so far?
Yeah.
Yes.
Yeah. So now that we get delta y, if we just print it out, delta y, it should ideally give us whatever the number is. Now let's see if we get the same answer as they do here. For example, sorry, where is it?
Further down, yeah.
Yeah, further down, right?
I think it's actually
Testing.
in the part 2, yeah. It is
Yeah.
where a little bit more down, and then here.
Yeah, this also, right? Yeah.
Yeah.
This is the result. So let's try. If we get 100, 100, I mean, okay, yeah, this is what it is. So the trader did a trade of 10 token asset 1 to asset 2. So in our case, delta x would be 10. And the original state, which is x and y that we need, is 100 and 100 in the AMM. Did you do you guys can you all make the connection that R1 is X
Yeah.
for us,
Yeah.
R2 is Y for us, because
Yeah.
that's what the amount of tokens in the pool were, and
The
that's what
only-
the Genesis state is saying.
The only thing we now need to replace in our little script is the y value, because we had it at 20 and we need to put
Yeah.
it at 10, I guess.
No, it's 100, no? Or Y is 100.
Sorry, 100, sorry. Sorry.
Yeah.
Yeah.
Delta X is 10 itself.
That's
But
good.
let's, the thing out here, okay, this is the wrong one, sorry. Yeah, we have to go here, but same thing. I mean, it's gonna trade once. What we want to do is, what we should get is, what we are getting is delta Y. And what we need is, like, what this is telling us is how much Y is left
We
in
need
the,
y2. That's what we need.
The pool.
yeah.
Yeah.
So what we need is Y,
Minus-
Y minus delta Y. In our case, it'll be plus, but because of the way we've defined it. But basically, if I'll type it as Y new is equal to Y plus delta Y. So if we print Y new, ideally, in the next state, we should get the same thing as they're getting there. Yeah, 90.9. Right? Because what this was, here. This was how many tokens of Y are left in the liquidity pool, in the AMM, sorry, after the trade, and delta Y was how much came out. So what we need is how much was left, how much initially was minus the amount that got out. Yeah.
Yeah.
Do you all have a question?
No, that was very understandable how to translate. Thank you for that.
Yeah.
At least
I'll
from
leave
my
this here.
side. I'm not sure. Oh, Strata Trader is here. Yeah.
Oh, hi, Strata.
Good morning.
Hi there.
Sorry, I'm late.
No problem.
Well, we're
44.
not in school. It's all right.
Minus 44 where I'm at, so it's really cold.
Okay. Lovely.
Okay.
Yeah. So, I mean, what we were doing was just trying to convert. I mean, I was showing them that anytime you have an equation, generally this is the right approach to solve it simply. Like, we separate out the numerator, we separate out the denominator. The reason we're doing all of that, by the way, is because it's very easy to get all of these things wrong. Like, if you try to do it in one section of code, of course you can do it. But it's just easier to, like, segment your code and write out different variables, simply because if anytime there is a change, if anytime there's an error in your code, it's very easy to debug, because I can just print out what the numerator value is or what the denominator value is, like when I'm debugging later if something goes wrong. So this would be an approach that will work for y'all. Again, y'all can change the names, y'all can do whatever, but this again works for me usually. So this is basically what they were doing too. If you actually look at what this section of the code is doing, I mean, at least this section of the code is doing, in some sense it's the same. Let us try to see actually. Minus y into delta x should be here, right?
Yeah.
Yeah.
The only difference is the fee factor.
Yeah, p factor we can ignore for now because it's anyways 1 in our case. And 1 into anything will be the same. I'm wondering why don't we have into delta x here? Oh, it's here, but that's in the denominator? That's strange, right?
No. That's correct. I mean the plus.
But I guess this is with fees.
Okay, no, I think maybe this is how it is. This is how to read it, I guess.
No. Rohan, are you sure that you can ignore the fees? Because what is the fee? The fee is
0.
what is it?
Fee is 0.
Fee is 0. Okay. If
Since fee is 0, fee factor is 1. So if a fee factor multiplied by anything will stay the same.
Yeah.
Right. We can even derive that if you guys
What
want.
is the fee factor?
It's just, so basically when I tried to do the math around this, and what you realize is anytime the fee is being used, it comes in the form of 1 minus something. 1 minus fee is the form in which it's coming. So they just created a new variable called fee factor. We can go through the math if we want to. Like for example, because the fee math is a little complicated, but let's actually okay. There is a section called adding fees, right?
Actually, yeah, they've actually given a problem. And,
Okay.
they haven't given a formula, but it's easy to derive the formula. That's not.
Yeah. Yeah, but if we can find it, we can just. It must be in chapter 3, right?
Yeah, three.
Chapter 3, I think fees and introducing fees. Yeah.
Yeah.
Mm.
Scroll down.
This I think we've done this before. Me and Stella. Not this, but the there's no equation directly given, right, for us.
No. There's no. Yeah. We can just use that problem.
Yeah.
And actually convert
Yeah.
it into an equation.
Yeah. So yeah. Okay. One way to
Come down to the last. Yeah. Sorry. No. Sorry.
Out here?
I'm sorry. No. That's invariant.
Right. So I'm wondering. 5% was the fees, right? So
Yeah.
I'm
So
thinking
why
of
do
this.
Is equal to invariant divided by
This one.
This minus
Invariant divided by
yes.
extent.
Yeah. No. Go up.
Up as in like in the image.
Yeah. This one. Sorry. What I'm saying is that just go to the above, calculating new
This one.
invariant. Yeah. This is by new. Go to the 300 minus 0.05. Just convert that.
Okay, this one. Okay, I see.
You get the formula.
Okay. I mean, the way I would go about it again, like maybe they've not given a direct formula, but the way I would go about it is the fee will be taken out from the delta x, right? Like in the sense like the amount that we are trying to trade, the fee will be first taken out, and then the entire calculation will be done. So delta x will reduce. So the actual what will happen is at any stage you'll have delta x minus delta x into the fee factor, like whatever the fee is. So at any stage you'll have delta x minus delta x into fee, and if you take delta x out, you get 1 minus fee, which is the fee factor that they're talking about. If any of that made sense to you all. Wait, let me do it on keep. Wait, I'll shut this. Okay, whatever. We'll do it. And maybe I can do it here in the math itself. Out here. So like delta x. If you're trying to remove phi into delta x, because phi will be always removed from the delta x itself, right? So let me remove this. This, by the way, I don't know how to do it in math. Should I do it in LaTeX? That's probably risky. Yeah, delta x. This I'm doing the math, by the way. And Stella, you will have to tell me if this makes sense to you. So basically, the new delta x, let's say, which is the delta x after the fee is removed, this will be used to calculate everything else, right?
Wait, delta
So
x
whenever-
minus delta x?
Into fee.
Oh, but then it needs another bracket, no?
No, delta x into fee minus delta x. So,
Okay.
So what will happen here will be again delta x. Ignore this is not Python, by the way. This is just the math that I'm doing.
Yeah,
What
I
you
know.
can do is you can take the delta x out and you'll get 1 minus fee. If this algebra makes sense to you all, because delta x will be multiplied by both later, then basically you'll realize that whenever you get fee, you always get it in the in this format, which is 1 minus fee, and therefore 1 minus fee was they just defined it 1 minus fee as the fee factor. That's basically what's happening, and therefore like fee factor is used everywhere because I don't know. We could have just used phi everywhere, but it would have come instead of this. You would have written 1 minus phi.
But 1 in this case is the agent, right? It's like no, it's wait.
What is the agent?
Because it says in phi factor, it says 1 minus state, right?
Oh, it says, oh, no. 1 minus state is just whatever state the system was previously. Like, I mean, before the trade. So we're doing state of the AMM and we're taking out the phi, which is written within AMM in our code. Like, the AMM has the information of phi.
Got you. Okay.
Yeah. So we go inside the dictionary, search for AMM and then search for phi, and that gives us 0. So, yeah.
The
If we change it
advantages
to,
of a nested
nested.
dictionary. Okay. I
Yeah.
got it.
Just to contextualize that AMM is the one that has fees and how much tokens they have. Yeah. So yeah, that's pretty much it. I mean, like if we can do this for any equation that we have, just break the numerator, break the denominator, then converting it to code becomes pretty easy because we did this. Now, the way you transfer this into a function is literally just create a function on top. Like this is what I would do. Oh, sorry. So I would define new function, whatever I want to call it. I will, right now I'm not defining anything. I'm just saying return 0, right? So all it's going to do is return 0. Now I copy paste all of this inside the function. Oops, and fix the indentation.
Oh, how did you do this so quickly?
That's
Cut and paste.
the tab indents.
Tab.
If that's what you're.
Great.
Yeah.
Okay. Sorry. Thank you.
Yeah. Yeah. So like if the indentation is wrong, I just tab it.
Cool.
Yeah, I'll remove this. And instead of returning 0, we'll return y new.
Yeah.
In our case, is that what we
prints
want?
it.
Right. In our case, we actually don't want to return anything. We just literally want the code to subtract these assets directly from the state itself. That's what we're trying to do. So once we have y new, like once we have this entire section of the code is just there to calculate y new, I can actually just then basically do whatever this is, which is, let me go back and see if I take the state, within the state, I know that within the AMM, whatever the asset 1 was, so in our case it'll be x, we wanted to increase, does that make sense? Plus equals to by the amount delta x, right? Because delta x was added to the system. Then what else we want is we want, and currently we have not defined state, by the way. I'm just doing this because I'm going to define state here. I will do state as some nested dictionary, which has AMM, which has
Trader,
Trader.
the trader.
yeah, it's making sense, right?
Yeah.
We'll have a trader, comma, and we'll have a liquidity provider. And within the AMM, we will have another dictionary, which will have all the information of how much token X they have, which will be whatever 100. Y will be 100, right?
Yeah.
And these will be again, that's just the syntax. We're gonna label them as, because our keys have to be strings. What else do we have? We have X, Y, and pool shells, which currently are 0.
We also have
got it.
fees and what's the? I think we have one more thing.
Yeah, fees. I think fees is all that we have for AMM.
Oh yeah, and shares. Sorry.
What does data have? Again, we can pretty much write anything, but in our case, let's just copy this because we just want, like, right?
Yeah.
So currently
Correct.
they have this, and liquidity provider will probably have something like, I mean, we can put anything, but X, Y, and I think shares also 100. Doesn't matter. Right? They could have this in their wallet, who cares? And what we want, so we're going to pass state to the function. So this will go into the function, and out here we will start making changes on it. So we will add the amount of X that was added by the trader. We will into the AMM. We will remove the Y that was in this case plus equals to, again, because Y itself will be negative. Delta Y will be negative. So we'll have delta Y and state. I think trader will lose some X, which will be the same amount as minus equals to delta X. And trader should also gain Y. So trader will gain delta Y. Gain in this case again will be negative because we've defined it. We've defined it as a negative out here. So it's always going to be negative, and in our case, the trader should lose it. So again, if we remove the negative sign, we can flip these, and it makes more sense conceptually. But again, like that's just math. We'll be able to figure out where the negative signs are missing. And yeah, so we return nothing, and we just do this, and we print state after the entire thing. And this basically this function should.
Why do you return nothing?
Because we are making the changes directly on the thing that's passed. Right? Thus, we pass the state, which is the dictionary, into the function. Then we make changes on it. And when we print it again, the changes will be reflected outside.
Okay, this is a Python functionality.
Another way you could have done that, by the way, is this. I mean, it wouldn't make sense. Actually, let's not do it. Yeah, it doesn't make sense.
Yeah, no, the thing.
And now,
if you return it, I mean, if you put a return and you put the function name, basically what happens?
No, you would not return a function name. You would return something that you want the function to print. So these are called fruitful functions. I mean, that's one way to put it. Like, for example, if I just have a function, let's say, give me a random name, right? I'll just call it function 1 again, function 1, right? If I return 0, versus I could have defined a function, which is function 2, which returns nothing. It doesn't return anything. It just does, let's say, 1 plus.
When you say return means printing, correct?
No, that's okay. That's the thing. That's very. I'll go through this. So let's take this function. This function just prints hi every time it's called. It takes nothing. This also function takes nothing. This function returns 0. Or okay. Let's make it return hello. Okay.
Yeah.
Just for context. So what will happen is, right now we are just defining them, right? So nothing's going to happen. When we call them, if we call function 1, what you can do here is I can.
It's missing a T. It's missing a T.
Yeah. What I can do here is I can define a variable called greeting, right? That takes this, and greeting 2, another variable called greeting 2, which takes the second function.
Yeah.
Or let me do this in another line because I think this is important to understand. What's going to happen is when we run this, first we define the functions. I just call function 1, and let's try to print what greeting was, right? Now, greeting actually became, you'll see it actually became hello. So greeting became hello, right? So what happened was we defined function 1, it returned hello. So this thing became hello. And then greeting became hello because of it, because we assigned it to that. right?
Roro, return, when you say return, it actually returns the value of whatever you have returned into the
Correct.
function.
Correct. That's the output of the function. So the way we visualize functions is it takes inputs,
Yeah.
and it returns an output. This is the output. The,
Okay.
the body of the function usually have some computation that helps us to get that output. Right?
So,
In this case, it's
yeah.
just pretty random.
So,
But
yeah.
let's try running this. Remember, for function 2, all it's doing is printing high.
Yeah.
Okay? So when I do this, it'll
Oh.
print high, but if I try to say greeting 2,
Got you.
it actually prints nothing. And if you look at type of greeting 2, it'll be none type. While greeting, if you look at type of greeting, which was the function where we return something, it'll be a string. So what happened here is actually function 2 got called, it printed high out here, but it didn't assign it to greeting 2. It just printed high because we ran the function, and it printed high when it ran this.
Interesting.
It didn't assign it to greeting 2. So the reason, when we return something, it's usually to take an output and then assign it to something outside that function. So ideally, if you ever want to return something, so the way you would do it is, here in this case, we would write the function will be called calculating delta x, delta y.
Data buyer.
I'll do all of this outside the code. Right. So, and I hope this works, yeah, okay. And we return y new.
To a new variable, Rohan? Is that what we're doing? You're outputting it to a new variable?
Yeah, maybe this entire approach is a little confusing for you.
Okay, it's okay. Carry on. I'm following you. Maybe I was thinking something.
Okay.
I think you're doing right.
No, I actually couldn't hear you. You said variable something, but
Oh, no, I was just saying that, can you hear me okay right now?
yeah, I can hear you. Yeah.
I was just saying that when you said you're returning something to y new, what you're saying is that when you run this function, you're returning it to a new variable. Whatever value that is, you're putting it into a new variable.
Yeah, whenever we call calculating y,
Yeah.
if we assign it a new way, like new y, let's say,
Yeah.
and we when we call calculating y,
The output into that new value.
yeah.
there.
So sorry, it's a function, so we have to do this, and we have to pass the state to it. What will happen is calculating y will be run. The state which was here will currently, like, I mean, it doesn't matter because we are not doing anything with it, but it'll run this function. X will be assigned to 100, y will be assigned 100, delta x will be 10, numerator and denominator will be calculated, this will be calculated, y new will be calculated, which we did earlier, then we return it, and new y, or anything that you call this, will become the output of your function. So but if we don't return, that's not what will happen. So there are two ways to run this, and that the way Andrew has gone about it, like in the code, is he has basically actually made the changes, all of the changes that were made to the state were happening inside the function itself, right? Like we are actually changing the state itself within the function, and that's why we have to pass state to it. I don't know if any of these concepts are we are not understanding. We should probably go through W3 schools for Python and go through functions. If you guys need that, let's do that. But yeah,
Just one clarification, Roro.
yeah,
When you said return y new,
yeah.
my understanding was that this y new is inputted into the function. But
No.
what's happening is that when you say return y new, it actually evaluates y new, correct?
No. So what happens is the function itself, y new is calculated here. Like this is the body of our function.
Yeah.
It calculated y new,
Yeah.
and then we are just returning it. Like we are taking it out of the function. So because the logic will be this, right? Ideally, this we will first of all never define x and y and delta x inside the function. What we'll actually do will be x is equal to state state AMM and whatever the x is inside the right, because that's how we want to actually get the state from this dictionary, not predefine it to be 100.
Yes.
Yeah, and same thing with y. We will do this here, and we'll change this to y, and delta x will not be in the state. It'll be another thing, ideally, and it would be the way Andrew called it was inputs, or we can call it trade info. And when we call the function later here, we will pass the trade info, which will be who does the trader, and how much delta x are they trading? Let's say 10. So when we call the function, we're gonna pass it the current state of the system, and we're gonna make trader trade 10 tokens. And that's what we'll do here. Like it'll take trade info and trade info. And if you look at when it's called trader, will trade 10. So it'll be 0 and 1. So we will go, we need 1. Like we need the second input inside this. And who does the trade? Again, like I'm trade info, not trade info. Trade. And agent will be defined as trade info 0. Because the first thing we're passing is who is doing the trade, and second thing we're passing is how much delta x are they trading. And that's when we'll make the changes here itself. We'll remove the return. So we'll have AMM will always be changing, and this will not always be trader. It could be something else. In this case, we have predefined it to be agent now. So basically, the way we'll use all of these functions is this. We will, because again, like if I can just do this, and I can do it again, calculating. Maybe we named it wrong now, because it's not calculating right, but state. We can do 2 trades at a go now. Trader, and let's say he does 20. So, and we'll try to print the state after. So what's going to happen basically, if y'all have followed through, is that we'll first define the state of the genesis state or whatever. Then we will define this function. This function, in fact, won't even be defined here. It'll be somewhere on top, somewhere like here. So we'll first define the function, like this is how the calculations will be done. Then we'll define the current state of the system, and all we have to do, we don't even have to look at now what the function was, what the math was, doesn't matter. We just run this, and it'll do both the trades for us. And you look, the trades have been reflecting. Like twice, x has, x added. Yeah, that makes sense, right? AMM got 10 and 20, so 30 total. So 130.
Yeah.
Does that make sense, Stella? Mm-hmm. Mm-hmm. And whatever the calculation of y was happened here.
Thank you for always reconfirming with the dumbest member of the group.
Yeah.
No. But I really, I honestly appreciate it. So far, I have no issues. I'm totally getting this. I'm not sure, like, it will definitely take me time to do this by myself. It's not like I would be like, oh yeah, sure, Rohan showed how it's going to be, right? And then I just like, like a little hacker girl, write it all down in code. That's not going to happen.
It's something totally different if you are sitting alone at home.
Yeah, I know. But
it is.
I mean, there's nothing I can do can change that. You'll have to go through the process of making mistakes and.
Mm-hmm.
Oops. Oh yeah, I have to first define. So generally, I'm saying like the way Python code is structured is all the math that we do we'll first put that into functions earlier. First, in fact, not even that. First, we'll actually the way we did it, right? Like first, we'll just do it, literally, do it without a function and just see if x is 100, y is 100, delta x is this, and see if our answers are right, right? Then we push it into a function, and we start abstracting away things. Like we start saying that, you know what, x will not always be 100 and y will not always be 100. So let me just put that information in state and pass it to the function. So that, because after the first trade that happened, what happened here actually? Trade x for y is not defined.
So,
yeah, okay.
So the idea is to first kind of like take it very literal and translate the literal math into a script, right? And then as you go, you abstract and abstract and abstract further and further and further. So you get like more to like a concise function. I think script, right? I think one part is obviously that, you know, then it becomes more functional in the sense of you can change certain parameters, but you don't have to change like the whole system again. So that's one preference, or this is like one of the pro points, right? But the other pro point is also when we're thinking in Solidity code, as far as I understand, every line of code costs you essentially on the chain, right? So you want to abstract away as much as you possibly can, so the code gets as light as possible and therefore as costless as possible.
So I would frame it differently. I would frame it differently. So with Solidity, it's not that every line of code costs you. There are two things that cost you. It's either memory and computation, right? So and there are many rules as to what actually costs us. Storing memory actually costs a lot. Certain computations cost lesser than other computations. So there are a lot of like rules around it. But as a whole, you're right. Like that we want to. It's basically what I was trying to say is it's not that just because you reduce the number of lines of code, you'll be better off. Because sometimes your code actually stores a lot more in memory, and it actually, or it could be like terribly written, and no matter how short it is, it could be really badly written. That actually you're doing same calculations again and again and again. So it's not the lines of code. It's how much compute and memory does your code take?
But still, if you're being very concise and abstract, I would assume that you don't have repetitions of code, right?
Right. Yeah. Yeah. Exactly. Yeah. So the reason, you're right. The reason we are writing functions is to make sure that if we are doing the same computation 10, 20 times, we have it pre-written once, and then we just call that same location again and again. Another reason we do that is, if you really think about it, every time I want to do a trade, I want trader to do a trade. I don't like all the information I need. I should, like, in terms of UI UX, right? Like the way I'm seeing it, all the information that my code should take from me is who is doing the trade and how much are they? What is the state of the system? Who is doing the trade? How much are they doing? And that's what the function enabled us to do. It made us just, and we can do this for LP now. In the middle, let's say liquidity provider did certain trades in the middle. Now, this is where we went wrong. If you look at, because I made them do so many trades.
Wait.
You actually.
The pool is drained. Did you drain the pool? Is that
I mean, I made them do 100, 200, 200, 200, 200. Yeah.
That's
by the way,
supposed to happen.
but by the way, you can see this. The pool will not drain at all. Like, it'll get harder and harder. Like, even though these guys are broke now completely and they are in debt. But all of the white just didn't come out. No matter, like, even if I do 1,000, like, let's do just one, it doesn't matter, right? Like, we'll remove these. You just do one trade of like, whatever, these many. We'll put that many X's inside. Y is still a positive now.
It's crazy. That's so cool.
So basically, the bonding curve never allowed Y to go to 0, because it never reaches 0. It just keeps going towards 0, but never reaches 0, no matter how much X you add.
But it's still pretty devastating for a trader. Right.
The
pool doesn't empty out.
Trader's gone. Yeah. I don't. Yeah. Now, also, this is the wrong thing because ideally, this trade should have never gone through because the trader's wallet never had this money to begin with to put like whatever these
Yeah.
number of zeros of trade. So
Oh.
that's when we need to add some code within our function itself, which is a safety mechanism, which basically says if um, if the state, if in the state of like the trader, like the agent, right? If the amount of token X they have is less than or equal to or less than,
Delta
whatever.
X?
Yeah, less than the amount they're trying to trade, which is delta X.
They're not allowed
Then
to perform the trade.
yeah, then just return whatever, none. I mean, in this case, what return is doing is okay. Let's not do it this way.
Yeah.
We can do it this way. If the amount that they have is greater than equal to delta x, that the amount, so this is a valid trade, then we'll put all of this inside the if statement. So what will happen here is first it'll check, is this condition true? Only then the rest of the code will run.
Yeah.
And
Only
else,
then the trade can even be performed, right?
yeah.
And if it's
Else-
not applicable, then
We'll just print
Hello.
not possible. Yeah, or ideally you'll
how
ideally
dare
what you
you
do
trying
here
to
is
do this? This is what you should say.
what should it say?
How dare you trying to perform this trade?
There you go. You broke.
I love this.
Okay, so yeah, we saved this code and now we actually try to do this. And how dare you broke and nothing changed.
Yeah.
Yeah.
So cool.
Yeah. So now we also added the safety function of in case the trade in case the trader tries to trade anything more than what they have, then it just shouldn't happen. That's it. Yeah, so that's basically all the code is. What happens later in the section of module 4 is basically this, that instead of doing these trades like this and every time calling the function, we actually use one more level of abstraction. Like what we try to do is we write a we put action list. Yeah, we call it action list. So list of actions that are gonna happen, and we put it in a list, and we the way we can do this is like this. Ideally, I mean, this is one way to do it, where I would just list out the actions that are happening, and I think that's a easier way to do it than the way it was done again. What I'll do is, I mean, like first action is this, right? Let's say we are just doing two actions for now. This and then liquidity provider takes 200. Also, let's make them like smaller numbers so like the trades go through. So what we'll do now is define the state. You define a list of actions that we want to do. There are two actions that are going to happen. And this could be like 100, 200, 300. It could be a CSV file that we could just put into this. So when we are making a digital twin, we'll ideally take a CSV file or have some kind of API calls that'll store it in a list like this and then run this function. And I will actually make it run it for action in action list. This is one way to write functions, for loops. I will say, this is going to be a problem. Yeah, we've written it as functions. Sorry, my bad. Okay, we'll have to do it the way Andrew did it.
Yeah, if you can explain that, will be nice.
Okay, cool. Okay, let's do it the way Andrew did it. So okay, let's just pass one thing first. The way Andrew did it was we write the function like we give our action list to two sets of information. Okay, one is
Rohan,
yeah.
Can you just cut and paste that, because the syntax in that was very confusing for me.
Okay. Yeah, it was confusing. I agree with you. This one, right?
Yeah.
This entire section, yeah.
Yeah. in fact, if you ask me,
Yeah.
I mean, a lot of Andrew's thing really throws me because he's not very rigorous in his, what do you call it, in his right. See, like, where where has state been defined as a dictionary in this thing?
Or is defined earlier in the year itself.
No, no, you define that. But
Yeah.
in Andrew's thing, show me where he has thing. Actually,
So, like,
defined.
again, when you're defining the function, you're not telling you're not telling. That's the difference. Maybe because you come from like a older coding, this thing like C++.
I'm not a coder. I mean, the stuff I do is Fortran. I mean, come on, man. I mean, this is
Yeah.
primitive. I mean, you can't call me a coder.
Okay. No, but I'm saying like the coders who've done C++, etc., right? A lot of them get stuck up here because what happens is we are defining a function. Even if you look at my code, for example, here, right? I defined state and trade info. Like I said,
But you define. See, Genesis.
no, hear me out, hear me out.
Yeah.
I write a function, I say it'll take state and info, I actually use it, but I define the state afterwards. So the code out here actually didn't know what state was at all, because state was never, I've never written what state is. But in Python, what happens is when you're defining the function, you don't need to tell it what state or trade info is going to be. You just need to say that there's something, there are two inputs that are going to come and one output that's going to come out or something, or no output that's going to come. That's all you need to tell the function in the beginning. When you're calling it, when I'm calling the function, which I did it here, right? Like when I'm calling it later, when I'm referring to it and when I'm using it, that's when I need to tell it what I'm passing through. When you're defining it, you don't, for whatever, like state could be like a list, it could be a dictionary, it could be like a variable, it could be anything. And the code will not really doesn't need to know in the beginning. When we're calling it, when we're using the function, that's when it needs to. This code basically does not run until it's called later on, like until it's called like this. It just defines it, it stores the name, let's say as, okay, this is a function, this is the name. Whenever this name is called, we go to this section of the memory and run this, whatever section of code was there inside the body. If again, like the only takeaway mainly from there is that your code does not need to know state or trade info or any of the inputs until you call it.
No, where exactly have you called and how does it? Yeah.
This is called calling.
For state.
Calling means I'm using the name of the function which was defined earlier. So when you're defining it, you say define the name of the function, and then it'll have two inputs, the body of the code, and then return or no return, whatever, right? And in this case, and when you're calling it, you use the same name that you used before, and you pass the number of inputs that you used before. If I don't, let's say if I just do this and I don't tell it what my second trade info is, it'll give me an error. It'll be like, it is missing one required. But it doesn't throw me an error when I'm defining it, because it's just it has no context as to what that thing was. Wait, let me just, yeah. Again.
Yeah. Okay. Fine. Yeah. Okay. This is fine. The only thing is that anyway, the fact that a state was I mean,
I would suggest again, like going through W3 School's ka function section.
I went through that.
Okay.
I couldn't figure it out.
Achha, okay.
Okay, let's go.
Okay. If there's specific doubts, I think we can go back to this. But let's try to move a little, and then we'll come back if we have specific. Because again, once this is written, right, you kind of don't have to go through this process again and again. You just have to copy paste code and just make changes, right? Like it's not really something that you have to ever code from scratch. Most things you don't code from scratch. So this looks daunting, but this is something you'll pretty much never have to do, because you just literally Google nested dictionary, copy paste, and then make changes in it. That's basically how you code the whole time.
To be honest, I don't think any one of us need, needs to code. I mean,
Yeah, with ChatGPT especially not now.
no. The thing is that I've had teams for me developing major code which was inaugurated by the previous Prime Minister of India,
Okay,
and
wow.
I didn't even know what. I could never code.
Okay.
I mean, I don't think you need to code to
So,
actually develop software.
yeah.
I think
No,
it's
but I
like,
agree. Yeah.
it's like with everything, right? It's not about like being able to like if you're a creative director of a brand, right? You don't need to be like a crazy good illustrator or a crazy good at Photoshop, right? But first of all, you
Yeah.
need to get to that position. That's one part, right? And the second part is also that you do want to know, what kind of tools should be used, what kind of elements, what kind of building blocks, right? And so having a fundamental understanding, especially in, I'm sorry, Kojak, in the younger generations who are just starting out, it's like, right? It's like, it's really important, I think. So, I'm also not playing. I mean, Rohan knows this. I'm not planning to become a super hacker girl, right? This is
Yeah.
like not my
Yeah.
goal with
Fortunately
this.
for us.
Yeah, I
No,
also
the thing is,
will never be, by the way. But yeah.
I do believe that I've got a very good feeling of coding, but the thing is that blockchain is a different ball game together. It's got a different feel, so that's why I'm just
I
putting
mean, on
myself.
the other hand, it makes things just easier, right? Somehow we are standing on the shoulders of giants and using basic elements of code that have been written, I don't know, 1,000 times. It makes it easier for new users to get into it, right?
Hmm. Yeah.
Sorry, go ahead.
No, you were saying something.
Oh, I was just gonna just make an observation, maybe just a general suggestion. So yeah, I think Rohan, I think you mixed up Kojak with me. I'm an ex-developer, C++ and whatnot, right? And
Yeah.
so I sometimes get a little I overcomplicate, my understanding from the old days of development. But I was just reflecting on everything that we're going through, and if we have an acknowledgement there to say that we are not going to be full-fledged, Solidity developers, right? And we only want to have a level of depth to understand code, then maybe it would be so that what Rohan you're doing is excellent, but maybe what we do in our visual learners group is let's create little quizzes, right, on snippets of that code in a very modular form. And what I mean by that is let's take very early stages of the code and let's put a little pop quiz. Here's the code. Tell me, is it option A, B, or C? Is it telling me this, or is it doing this? And that way now, and the only reason I'm saying that is that, look, this is just a suggestion, but we don't have to take it. But I'm just thinking, if we all have an acknowledgement that we're not going to be, the hacker, the cyberpunk hackers, right? Then why not practice more of deciphering and understanding the code and not get to the granular level in which we feel that we may need to code. Now, that could be just, I don't know what other people think about that, but I'm just reflecting on that now, and I'm thinking, yeah, maybe that's the way it should be if we don't have that time and luxury to do that. I don't know. That's just a bit of a ramble, but I'd love to hear other thoughts.
Yeah, Sarah, you're saying this because you feel that there's a need to understand code, Python code, correct?
Yeah.
No. Sorry. The reason why I'm saying that, I'm saying that it's important for us to. Yeah. Okay. Yeah. Kojak. Yeah, you're right. It's important for us to. No. It's important for us to know what the code is doing. It doesn't mean that we have to understand every intricacy of the code. That's what I'm saying. And now, I think there's a very fine balance between that, because understanding what the code is doing, you have to have a certain level of comfort in reading the code. But okay, so maybe that's, yeah, I guess now that I talk it through. I guess that is what I'm saying, Kojak.
Yeah, Rohan, yeah, thanks, Sarah. Can you just explain this? Okay, I understand this history is equal to copy, deep copy state.
Yeah.
I understand. I mean, I understand what deep copy is. But this particular, so this is exactly what's said what you said. This thing, the action for action in action stack, and then action 0 to this thing. So is it part of? I mean, what is this action 0?
Yeah. So what I'll do is I'll first remove this, and I'll do it separately without the sections. So I'll create an action list. What the way we are imagining this happening is, first we tell it what action we want, what action we want the first step to be, and then who's doing the action and how much they're doing, right? If we give it all that information, like that's what the information was here, right? For example, what action is happening, and who's doing it.
Yeah.
We'll assume now that the state is something that the code knows. Like we'll just pass the state, do a bunch of actions, and then try to find out what the end state is. Okay. So instead of passing state every single time, what we're gonna do is just say first act. What is the first action? What is the second action? What is the third action? And how? Who and how?
Action,
Yeah.
The specific action.
Yeah.
That's excellent. Yeah.
So what we'll do is we'll first say that this is the action. I want to trade X for Y, and I want the trader to do it, and I want 10 of it to be done, right? So that's the first action. Second action is gonna be the same thing, let's say, but I want the LP to do it, for example, right? And third action is gonna be again, like let's say trader decides to do a trade and do another 20 of the trade, right? So let's say 3 things are happening. All currently, by the way, this is a function, right? So if the way I would go about this is I would say for action in action list, and this could be anything. You could call it I, X, Y, Z, doesn't matter. But when we call it here, it'll print. Let's just print action, right, to see what is happening. So this code will print. First, it'll print this, which is function trade X for Y at some location, whatever, and print this, right? So it printed basically this entire thing, but it saw this as a function. It didn't see it as, let's say, just a list. So the way the code is actually doing it is it's doing action. Let's print action. Okay, let's print action 0. So it only printed the first section, like only printed these, this, and this. Does that make sense? If I print action 1, it'll only print the trader 10, LP 10, LP 20. Yeah, we'll call it trader. Doesn't matter, but yeah. So action 0 is referring to action, by the way, is referring to the first action, and then second action, then third action. We are iterating through it. And 1 and 0 is calling this or this, like using going from this and this, because it's within. Okay. So the way the code is actually doing it is, since we know that action 0 is a function, this will become trade X for Y, right? And then we'll use it to call action 1. So all 3 actions will happen. Is missing.
State?
Yeah, we have to pass it state also. Right. Yeah, right.
No, 1 second. See, now that's a tuple, state action 1.
Yeah, it's not actually a tuple. What it is it's just a very cleverly hidden function call. So actually action 0 becomes trade X for Y, right? Trade X for Y. Or whatever the trade X for.
I've not understood this.
Yeah, let me do it this way.
Yeah, no, that line I've not understood.
Yeah.
Action.
So what I'm trying to say is this and this, let's call it action 1. This and this will be exactly the same. These two function calls will be exactly the same.
1 second. Okay, no, that.
Okay,
Because action 0 is
Dummy-
referring to this.
Dumbest member of the group is not understanding this. Sorry.
Okay. Right.
I'm so sorry. Where does
Okay.
action 0 come from?
Okay, let's do it this.
The youngest and the oldest.
Okay, let's do it this way. Let's hide these, and let's print. Let's just print action again,
Okay.
right? So if we print action, wait, I printed state also. Please remove this. Yeah. If we, and let me remove all of this also. Let's just not confuse ourselves. Okay. So what happened is, what this does, it's a for loop, right? And a for loop will, what the for loop is doing, like all this is saying is, for action, ignore this, in action list. So for something in action list, print action. And what it's doing is, first it'll go into the first element, then it'll go into the second element, then it'll go into the third element. Another better way to do it, easier for you. So let's say we make a list. List 1 is equal to 0, 1, 2, 3, 4, 5, 6. Okay. And if I write a for loop that takes I in list 1, notice there's no I anywhere right now, and print I, what will happen is it'll print all of the elements, and let me
In the list
not do this.
1. Yeah.
Yeah. So I became 0 for the first call, then it'll run again, it became 1, then it ran again, it became 2. Like it went through the entire list. When it got over, this section of the code stopped running. That's how lists for loops work.
Okay, got you.
Okay.
Yeah. Okay.
Oh,
No,
okay, okay, I understand now. Okay, fine.
Yeah.
Yeah.
But
got
instead
you.
of I could have called it number. And I could have called this number.
No, but can you, Rohan?
Same result.
Yeah.
Can you just this action 0 state action?
Yeah. Yeah. So let's go slowly now. So now we have understood that action becomes whatever the first element of the
Yeah.
code is, right? So if we print action, we should get the
The first, the second, and the third set.
So
Okay.
it got 3, 1, 2, 3, correct? Because there are 3 things that we passed the thing.
Yeah.
If we let's say print action 0, then it will print all of these, and let's print also action 1. You should be able to understand it now. Yeah.
Oh, it's 10. Yeah.
Yeah.
Okay,
So it
that's-
first
yeah.
printed the function, then it printed the second thing. So it first went here, like action became this. Action 0 is this. Action 1 is this. So it printed action 0, action 1. Then action became. Then in the next
It
call.
would be action 1, right?
Yeah. So this entire thing.
Action 1. What was
this thing-
marked?
This thing will be action.
Action 0, and the next one is action 1.
Yeah. Then action changes, and it becomes 0 and 1 again. And then this action is 0 and 1 again. That's why-
the for function just loops through the entire list, like first, like
Correct.
the first position, the second position, the third position, and then it lists in these like little nests 1, 0, and 1. Okay.
Yeah.
Okay.
Right.
No, yeah.
Now-
Rohan, can you just explain the syntax of this one? This action 0.
Okay, it's just going through a list. So if I had a
I understand, but I don't understand the syntax. I mean, it doesn't make state action. I mean, like.
okay, let's try it for the list number. You understood this one, right?
I understand the for loop. That's not an issue. But I
Right. So
don't understand-
let me do
I
it
don't
here.
understand the syntax. I mean, the only thing I don't understand is the syntax for that line.
Okay, when I do list 1, oh sorry. So let's say this is your list. Oh sorry. And I print. If I just try to print what list 1 is, what? So when you have square brackets, it's referring to a list, and we start counting from 0, 1, 2.
Yeah.
So
And then and then how do you get the stage action? I mean, how does that work?
right, yeah. So I'm getting there clearly. So what happens is if you looked at action 0, it was a function called trade x and y, right? Action 0.
Yeah. Fine. No
So,
issues with that.
so what? Basically, it's equivalent to doing this. Trader x for y state. This is how we would ideally do it, right? State, and then we would pass
No
this.
issues. No issues. How does that bracket state action 1 work?
Bracket state action on this one.
No. Come down.
No.
Next line. Yeah. This line.
Yeah.
Yeah. No. Above that.
Okay, this one.
Yeah.
Okay.
Just explain to me how this syntax works.
Can you recognize that? One sec. That these two statements. Okay, let me cancel this. Let me put this. Okay, can you recognize that these two things are very similar? The only difference is trader for x, trader x for y is action 0.
One minute.
Everything else is the same. Inside the bracket, everything is the same, right? These two brackets are the same.
Okay, I think I've kind of understood. This is a list, and this actually identifies a specific element in that particular list. All that it does is straight the same, correct?
Yeah. So the first thing is a function, and then we are passing arguments. So
the function. The function. It's a list actually.
Yeah, it's a list, but inside the list, there's a first element is the function.
Yeah. No, leave that because let it be anything inside the particular. But then you're calling the state, and within the state, you're calling you're defining trader.
No, because one sec, this is exactly the same as we did here, right? Like till now we didn't have an issue with this. This is how we were doing it, which was trader x for y. Then we're passing the state and the trade that's happening.
See, what is confusing me is that normally when we call something within a list, you have a square bracket, but here you
So that's the catch exactly, and you're perfectly in the right point. Like you'll understand this now. The reason this is a circle bracket, like normal bracket, is because this element action 0, which is this, is not is normally in lists we put strings, we put other lists, we put dictionaries, something like that. We'd never put functions so far.
Okay.
So the first element, like action 0, is a function itself.
So you needed to input certain variables, and this is the only way of doing it, is it?
Yeah, because we're trying to say that do this function and do this much of it. So trade x for y, who's doing it and how much are doing it? So trade x for y, the trader is doing 10 of it. And we're doing it here.
Okay.
I'm telling you, I promise you all guys, this is a very complicated concept because we are doing for loops, we are doing functions, we are doing lists inside functions, and then using functions to call, like it's just crazy. Like this is
okay, fine. Now I've understood it, and okay, fine. I got it. Thanks, bro.
Again, even if you don't get it right, for all of y'all who kind of zoned out, the more important point is that doesn't matter if you don't understand how this code was written, this one. Like, because there's history, there's deep copy, all kinds of weird shit is happening. Point is, for us, all we need to know is now that we can actually just say that first action that happened is, like, first thing that happened in our system is remove liquidity, LP removed liquidity of 5. Second thing that happened is liquidity got removed of 5. Third thing that happened, liquidity got removed of 5. If you can just read this action list, you don't need to give a shit about what this is doing, because this all it's doing is making these actions
Yes.
like loop
Yeah.
and giving us so if you look at the state this thing,
Yeah.
yeah, it's making all of the things happen, like liquidity of 5 will get removed, another 5 will get removed, and that'll keep on happening, like so 100, 95, 90, 85. So now it doesn't, this will be like a function that we'll save somewhere else and not even look at. But the main important point is I can just define an action list like this. And this is very easily to understand, that I just need to say remove liquidity, who removed liquidity, how much did they remove. Then I can change this to, instead of remove liquidity, I can change it to something else that I'd saved, like swap
Like
add.
add liquidity.
Yeah, swap to asset 2. Yeah, add liquidity or add liquidity. You're right. So let's do it, add liquidity. And if we run this, and if we run this, I think this should work. Okay, it won't work because we've not run all the code before this. Where's the run all option? Shouldn't that be there? Okay, never mind. I'll just run everything. Yeah, we'll go all the way till here. Where were we? Yeah, here, right? Let's start up. Oh, because action. I'm so confused. Shouldn't this run again? List index out of range.
Could it be that we haven't defined the function add liquidity?
No, so if you actually debug this, it says something in add liquidity, yeah, and something here is going wrong. Oh, maybe add liquidity needs more variables. Inputs 2. Oh, it needs 3 inputs for add liquidity. Why though? That's crazy. Okay, let's not do add liquidity. Again, for our thing, we just need swap to asset 2, right? We'll try to do it this way. Swap to asset 2, and we'll make trader do it. And we'll evolve the state, and it should run here. So now again, like, point is, now the state actually tells us every step of the way. First step, this happens. Next step, this happened. This is the state. Third step, this happened. Anyway, so again, crux of everything. Ignore all of this. Like, ignore this difficult copy history, whatever. Doesn't matter. The main point is that now we can define an action list, just a list of the actions that we want to do and how much of it we want to do. And just if we put that into this action list, into this function, that's it. Like, we're done. Like, the way I use it is, just I copy paste this. And define an action list for myself, right? That's all I need. I don't need the functions. I don't need anything. Like, this is how you use the code now. Like, the code's already been written by Andrew, right? How to use it is what's more important. Which is that I take the action list. Also, I come here, copy paste this, and I make changes in it. Oh, sorry, I did something wrong. Yeah. So I define a state, which is Genesis. This is all I need, because every other function has been already written. So Genesis state is this, right? Yeah.
I had some questions about the nice print function.
Yeah, ignore it. Again, even it just makes things print nicer, but we didn't use it, so it doesn't matter.
Oh yeah, this was my question exactly, because isn't it supposed to round down to like 3 decimal values? And I'm like,
yeah,
It
because I
doesn't
didn't
look
have
like
a
it.
nice printer.
oh
Because
okay.
if I used this somewhere, then it would have worked, but I didn't do it.
Oh okay, good. Okay, good.
Yeah.
That puts me at ease. Okay.
Yeah. So again, like, what I'm trying to say is all the functions, all the math, all the evolve function, whatever, like how to evolve state, everything has been defined for us now, right? Ignore it. We don't give a shit. What we give a shit about, do we understand how to define a state? Yes, right? You just have to say
Language, Roro. We're recording.
Yeah. No, because I'm trying to
It was very understandable.
yeah. Trying to explain that, hey, I know it's confusing, we ignore it. Because we don't need to redefine it again and again. That's the whole point of functions. They've been done for us. We just understand how it kind of worked. And if we even got the outline of it, that's it. Like, what we are doing is defining what the state of the system is. then telling it what actions are going to happen. And in this case, 3 actions are going to happen. Liquidity is going to be removed by liquidity provider of 5 amount. Then swap, then asset 1 is going to be swapped to asset 2 by trader 5 amounts, and remove liquidity will happen again. These are 3 things that happened. And if we just put that action list here and the state here, so we call it genesis, or we'll call this state, doesn't matter. What we'll get is a print of the entire state, and this is the end state. This was the initial state, this is the end state. Done. So now our code is evolving states. And we don't have to look at the functions, we don't have to look at pretty much anything from the past. So now we have a way to define a list of actions that we want our code to do, and it does it for us, and it prints it out. Are we relatively clear?
Yeah. It's
Absolutely.
Yeah. I just need your help in installing Collab, Rohan.
Yeah.
If you can help me tomorrow, it'll be great. And now I've kind of understood that they say basically what happens is that if you use, if it's something like a tuple, in the previous one, it treats it as a function input, correct? That's what you're trying to do.
Yeah, it was because the only catch there was that the first item in the list, where did it go? We wrote it somewhere, right? Yeah. The first item in the list of action, like action was a list itself, here.
No, what you're saying is that if you define it this way, then what happens is that what's inside becomes an input into your function.
Yeah. Because action 0 is a function itself, and now these are the inputs. It's not a tuple. Like
action 0 is a list, but if you put this tuple like stuff, it becomes an input into the action 0.
Yeah. Also, action is a list. Action 0 is a function. And this is a function call.
Action 0 is a function within the list.
Yeah, exactly.
Yeah. So action 0 by itself is not a function, but action 0 in the list is a function.
Correct. Yeah. Exactly. Yeah. And it will become trade X for Y because that's what we're doing here. Mm-hmm. And then if you look at it as just a function call of trade X. Yeah. It's confusing, but
it's really confusing. It's because I've gone through the Python stuff and all that, but stuff like this is not defined.
Yeah, and this is 3 very complicated concepts of loops, functions, and lists within lists. All of them stuffed into one. And the other thing that we're putting is state, which is a nested dictionary. It's just like everything that you're the biggest nightmares are all in one place. Yeah.
Yeah, I mean, without somebody guiding us through this, it's hell actually.
Yeah. Yeah. But again, the point is, doesn't matter. There are many ways to do it. This was one way they did it. It was confusing, but even if we ignore all of that, as long as we get the gist of how it was done, and we know how to use it. Now, more importantly, we know how to use it. Now I can go down and just define a state out here, this one, right? Define a state, make an action list, and use the evolve function, and everything is done for us. So this is the core feature of our code, which is Stella. Do you get it? This is the core feature. That's all we at the end of it care about.
Yeah, I understood that.
Yeah.
Actually, I'm pretty I'm feeling pretty confident about this. More than I felt about the math. I'm not sure why, to be honest, because it's a higher level of abstraction, right? But I actually do understand what's going on here. So, but also thanks to you, obviously. So thank you.
Also, sorry about the language, all the YouTube viewers. We are not even monetized, so it's not a problem for us.
No, it's fine. I just wanted to actually make a joke. It's okay.
Yeah.
Okay, I think we should cut it for this week. Thank you so much, Rohan. I was wondering if we should just focus moving on in the chapters for next week. Probably just honestly the same amount that we were supposed to prepare for this week, since everyone was slacking off a little bit. Yeah, Lutra, I got you. I understand. No, but I think it's... Wait, did you print these?
Yeah.
Oh, that's so cool. Did you have to import a library for doing this?
Yeah. I mean, in
Yeah.
the,
Plotly.
yeah, PLT. So that's
Yeah.
matplotlib. But I don't know where we defined it. Maybe all the way on top.
Probably, right?
Yeah, 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 yeah,
Yeah.
yeah.
Oh, this is super cool. This is so cool.
Yeah. Actually, Seaborn is like much prettier, and I usually use those. But yeah, this is what it is. Yeah.
No, but it looks great. I mean, it's still better than nothing. It shows that it never goes truly to zero, so that's
Yeah,
helpful, I
yeah.
think. I was wondering, should we, like Rohan and I, should we try and go on Thursday a little bit through like the exam questions? Instead of, like, I think we don't really need to do a pop quiz because we already have a real quiz to attend to, right? The exam
Yes.
questions.
Yeah.
So maybe
Yeah.
some of them could serve almost as like pop quizzes. Same that we
Yeah.
did with the math section.
Hmm.
Yeah. That may be a good idea because
Maybe 2 or
what I
3,
did-
right? Kojak.
Yeah.
Some are very hard. Module 4, some questions are pretty easy, and some questions are almost like advanced math level, I feel.
Okay. We
You know
could
what
try.
I did for, yeah. I mean for whatever questions were given in that this thing sheet, this thing. All the
One of the
programs-
questions was this, so I've already written it here.
all the coding stuff I did it in Excel
Ah, okay. Oh, that's cool.
because so the thing, but still there are some clarifications.
Yeah.
Because I don't think I'll ever code. I mean, like, come on, my coding.
Your coding days are over. Now it's only executive level, and he's like with a little whip, and he's like, "You code, you make user experience, you do graphic design."
No, Stella, we just define the problem, then we actually, lay out a way in which it can be accomplished, and then all what we want is the output, and iterate till we get it. That's all. We never go into the code.
That's convenient. I really have to do this in the sense of because I need longer to grasp these things, right? Be it math, be it coding. I just need longer for these things. You can, sit me in front of a very, very strange software and we'll probably pick it up in less than a week, right? You can sit me in front of, hey, learn a new language in the next 3 months and I will learn it, right? That's like super easy for me to pick up. But those things, they just take a little bit longer, a little bit more patience. So for me, it's also important to confront myself continuously with it, because then my visual brain will grasp it better, right? So for example, for East Denver, I applied for hackathon team, not because I want to crack the mainframe, right? But because I think if I involve myself more into it, right? If I get more familiar with it, then my brain will have an easier time picking it up. That's the truth.
Stella, you can actually play a very vital role in the hackathon team because you'll be able to define the problem. For certain types of problems, you'll be able to define much better than what coders can do.
Yeah.
Well, that's going to be my role, but my role is like product manager and UX.
For certain types of problems, which are say what do you call art? Whatever in your domain, you will be the better person to actually define it. So don't underestimate yourself in any way.
Aw, thank you. But also I'm not, don't worry.
Yeah.
I'm a gangster in another way. I'm just not a gangster in coding. That's okay, I think. Oh, look, Lutra's coming back. He's like, spinny dots, spinny dots, and then popping into existence. No? No.
Not yet.
You're
Does anybody play chess, by the way? Kojak, Lutra?
Sorry?
Do you guys play chess?
No.
Yes. I saw the chessboard.
Yeah. Well,
Yeah.
I'll show you. I'll show you a better one.
Believe it or not, I have a chess trainer, a Russian grandmaster.
Oh, who?
What? So dope.
His name is Sergei Kalinichev.
Oh, wow. Okay. Look at this chessboard. Like, look at these pieces. They're so good. I don't know if you can see them.
Yeah, nice one.
They're
Yeah,
hand-carved marble.
hand-carved.
Yeah, nice
Yeah.
one.
Jaipur, is it?
My dad bought it when I was born, like the day I was born, and he wanted to teach me. His plan was he'll teach me chess on this. It's a beautiful chessboard. Like.
Yeah.
That's so nice.
What's your favorite opening with white?
Bishop's opening, like e4, e5, bishop.
Okay.
E4.
And with black?
With black, I play. So with white and black, actually, I play the same structure. These are called. It's kind of like a King's Indian structure or the Purk defense. So King's Indian. Yeah.
I like Rati opening with white
lovely.
pieces, or sometimes e4 and then some crazy gambit stuff.
Right. I play
And-
Urusov Gambit. That's the only Gambit I play. Urusov.
And I like the Smith-Morra gambit.
Oh, okay. Wow.
Yeah.
Wow, I
It's
didn't
like I
take you
usually
for a
play some
Gambit person.
Brazilian defense.
I only watched, Queen's Gambit.
Ah, okay.
Yeah.
Nice. I've not seen it, but I should watch it because I'm so
And you
into
should.
chess.
It's a nice kind of mini series, and you will like it if you like chess.
Yeah. In fact, last year I started playing blindfold chess. So I was playing like e4, e5, bishop c. Like I would play it without seeing the board with my friends. And my goal is this year I want to be able to play simultaneous games blindfolded. Like I'm playing with two
Yeah.
players, but I can't see them.
That's really, really hard.
Yeah, I
You
know.
know,
And-
sometimes, especially with some weaker opponents, I did it playing blind. I guess one board, to
Yeah.
just have in your mind is quite enough.
Yeah.
My God,
No,
I can't
Yeah.
imagine you guys playing. I mean, forget it.
We should play an online game, Rua.
yeah, Lucha, next time we stream a game together, like live on visual
Let's do it.
All right.
There's
Okay,
actually,
cool.
I don't know if you saw this, but there's
activity.
actually in the activities,
Ah,
there is a chess in the park. I just started
Oh,
this
that-
activity, and
authorize. Okay, I
you
will
can-
authorize it.
I can create a game, right? And say, okay, random piece set. Let's go with Sky Isle, and the theme will be Sky Isle.
Just one second.
Whoa!
Rohan, can you spare some time tomorrow? Say what time would be convenient for you? You just tell me. You just message me.
Okay, yeah, yeah.
Whatever time, and I'll try to adapt to it.
Okay, okay, cool.
Or wait, I mean, yeah, may not be one session, but I don't know.
Yeah, we'll do it. Even if it takes more, it's completely okay.
Yeah, because kind of. Yeah, fine. Okay,
Yeah.
okay, guys. I mean, sorry. I mean, Rohan, thanks.
Oh, no problem. Yeah.
Uh,
We're enjoying playing a chess match here. So, Luca, this is the structure I play. Like, I shutter my bishop and I get this structure. Yeah.
It's some kind of King's Indian structure, right?
Yeah.
And you can play it against several kinds of d4, c4, even
Yeah,
e4.
exactly. Yeah. That's basically the okay. Stella, you're playing well now, by the way.
Ah, no, now I'm already stuck. I'm like, no matter what, you're gonna eat my little chump here.
Yeah, you can move it. Also, this was the only bad move. The knight going to the corner,
This one,
like
right?
into the knight to the a file shouldn't
one.
have. Oh wow, this
This
is
one.
also very bad.
No, this is the one I only moved. I'm not trying to win here. I moved it to tell you this is the one you meant. But
Yeah.
But yeah, I'm definitely gonna win this. So I'm getting out of this activity now. How do I cancel this? How do I cancel this? Let me out.
Yeah, I'll concede before you do. Game over. you
Right,
do.
so just to get it to the goal, we should prepare the exam questions of Module 4 for next week, or just going through the stuff once again and asking or clarifying some questions that might
I think
arise.
we should go through module 4 questions and see whether everything we've gone through so far does it.
Okay.
Yeah. I think that'll help.
Just a little bit, right? Like, I'm not trying to say we should, solve our exam questions next week.
Yeah.
Because I
Yeah.
definitely also I'm sorry, maybe I'm slowing down the group, but I still need like some time to go through this chapter. So yeah,
That's
definitely.
okay. I think
no worries
everyone will
about
talk
the pace.
Yeah.
I mean, we discussed it already. All of us have some other things to do, mostly a job. So there is quite not that amount of time at our disposal to be very, very fast. And I like it the way it is, I have to say.
And also, no one is like stressing us, right? The only stress that we have is the one that we give to ourselves. So it's literally, it matters like how comfortable we feel. There is no one, you know, after us being like, hey, you need to solve this next week, right? We don't. Like, I think it's more important that we actually do it and we get to the point of finishing all 5 modules. I think that's so much more worth than trying to rush through it and only understanding like, I don't know, 75% of it, right? So that's my personal attitude. I know Rohan is with me on this one. I guess you too, so that's fine. We're a small group now. There are no...
I'm joining on that.
Super shiny students, keine Streber, Lugdra, keine Streber sind wir hier. No, so we're good. Okay, guys, I also need to run. I see you later.
Yeah, okay. Bye, guys. Lutra, just not next time.
Bye.
Yeah, bye.
Yeah. Bye.